Welcome to Infint Universe with interesting episode. In a world already full of innovation and breakthroughs, Elon Musk has once again made headlines with Tesla's latest announcement. Tesla has introduced a brand new condensed super battery that can fully charge in just 15 minutes. This battery brings a big change with faster charging, much higher energy density, and driving ranges that can go up to nearly 1,000 kilometers. It's not just a small improvement, it's a big leap that could completely change how we see electric vehicles. What's even more interesting is the timing. Right now, companies in China like CATL and BYD are leading the battery market with their ability to produce large amounts of batteries at low costs. But Elon Musk is not just trying to compete with them, he's trying to completely change the game. When Tesla was first created in 2003 by engineers Martin Eberhard and Mark Tarpenning, the world of cars was very different. Electric cars were seen as strange, slow, and not very practical. They didn't go far on a single charge, and the batteries were expensive. Most car companies were still focused on gas-powered engines, and even hybrid cars like the Toyota Prius weren't taken seriously in many places. But Tesla had a different idea. They believed that the future of transportation depended on fixing the battery problem. They didn't just want to make stylish electric cars, they wanted to improve the batteries so much that electric cars could become something everyone would want to drive. From the very beginning, Tesla put a lot of focus on batteries. They didn't treat them as just another part of the car. Instead, they saw the battery as the heart of the vehicle. Tesla's first car, the Roadster, used the body of a Lotus Elise but filled it with over 6,800 small lithium-ion battery cells, the same kind you might find in laptops. These 18650 cylindrical cells were made by Panasonic, but Tesla engineers found a new way to put them together in a powerful battery pack. This was a bold move because no other car company had tried using consumer-type battery cells at this scale. It allowed Tesla to avoid relying on traditional battery suppliers and gave the Roadster an impressive range of more than 200 miles per charge. At the time, no other electric car could go that far. But Tesla didn't stop there. They wanted to build even better batteries. So, they worked more closely with Panasonic and started planning something that had never been done in the auto industry before, a factory that would make batteries from start to finish. In 2014, Tesla announced that they would build the Gigafactory in Nevada. When the first part of the factory opened in 2016, it became the largest building in the world in terms of area. The idea was to make battery packs on-site, which would help lower costs, improve efficiency, and allow Tesla to make more electric cars for the world. This factory helped Tesla make a huge step forward. The next big improvement came with the Model 3, which launched in 2017. Tesla moved from using 18,650 battery cells to a newer type called the 2170. These cylindrical cells, which are 21 mm wide and 70 mm long, were also made with Panasonic at the Gigafactory. The 2170 cells were better in many ways. They held more energy, handled heat better, and lasted longer. Thanks to these improvements, Tesla was able to offer longer-range electric vehicles at lower prices. This helped the Model 3 become the best-selling electric car in the world. Then came a major announcement on Tesla's Battery Day in September 2020. Elon Musk and Drew Baglino introduced a new type of battery cell called the 4680. This battery was a big change. It was 46 mm wide and 80 mm long. The 4680 cell delivered 5 times more energy and 6 times more power than the 2170, and it could increase the driving range by 16%. It had a tabless design, which meant there were no extra pieces inside to connect the parts of the battery. This design made it easier and faster to charge and also made it simpler to manufacture. Tesla also announced something new: structural battery packs. This meant the battery cells would actually be part of the car's frame, making the car stronger and lighter. Tesla made more improvements in how batteries were made, too. They introduced a dry electrode coating method after they bought Maxwell Technologies in 2019. This new process didn't use wet chemicals, so it was better for the environment and cheaper to make. Since 2021, Tesla has been producing small amounts of 4,680 cells at its factory in Fremont, California, and later expanded production to Giga Texas near Austin. These batteries now power some versions of the Model Y and the Cybertruck. But Tesla wasn't finished. They were working on something even bigger. That next big step came in 2025 with the release of Tesla's condensed battery. This battery was the result of 20 years of research, thousands of patents, and many changes in how batteries are built. Before it was officially announced, details were kept secret. But when it was finally revealed, it showed a complete change in battery design. Instead of using the usual lithium-ion technology, the new battery used a solid-state-like chemistry with silicon nanowire anodes and high-nickel cathodes. This allowed it to store much more energy in a smaller space. The energy density was over 450 watt-hours per kilogram, compared to around 250 for the 2170 battery. That meant cars could go farther, charge faster, and were less likely to overheat. The condensed battery is designed to be the future of energy storage. Tesla spent more than 15 years researching every part of the battery process, from the materials to the final design. Unlike older batteries, the condensed battery stores a lot more energy in the same space. This means that cars using it can drive over 800 kilometers on a single charge, and the battery pack doesn't have to be larger or heavier. Because of this, the new battery is not just good for cars. It could be used in drones, airplanes, or anything that needs power but doesn't have a lot of space. One of the most amazing parts of this new battery is the silicon nanowire anode. Most batteries use graphite, but silicon can hold 10 times more lithium ions than graphite. The problem is that silicon expands a lot during charging, which can damage the battery. Tesla worked with research teams and companies like Maxwell Technologies to create very thin silicon nanowires that don't expand as much. These wires allow the battery to hold more power and last longer. The condensed battery also uses a solid-state electrolyte instead of the liquid type found in most batteries. Solid-state electrolytes are much safer. They don't catch fire, leak, or overheat like liquid ones sometimes do. Tesla's electrolyte is believed to use a special type called lithium-ion, with added materials to make it work well at all temperatures. This makes the battery much stronger and safer, which is important not just for cars but also for planes, spacecraft, and military uses. On the other side of the battery, the cathode, Tesla is using more nickel and less cobalt. Older batteries had about 80% nickel. The new battery goes up to 88 or even 90%. This change helps the battery store more energy and also reduces the need for cobalt, which is expensive and hard to mine without harming people or the environment. Most cobalt comes from the Democratic Republic of Congo, where mining conditions are dangerous. By using more nickel from places like North America and Australia, Tesla is making their batteries better and more ethical. The condensed battery isn't just for Tesla's cars. It's designed to be used in many different ways. While Tesla will first use it in their cars, they also plan to use it in other products. In 2024, Tesla's energy team started using condensed battery modules in their big battery systems called Megapacks, located in Moss Landing, California. These new battery modules showed 38% more power and cost 25% less to cool compared to older battery types. Elon Musk has even mentioned using this battery in Tesla's humanoid robot, Optimus, and in SpaceX's Starship rockets, where powerful and small batteries are very important. Another major part of this battery is how it's made. Tesla has built a special refinery in Corpus Christi, Texas, which began operating in 2024. This refinery makes important materials like lithium and nickel, which are needed to build the batteries. By making these materials in-house, Tesla doesn't have to rely on other countries or companies. This helps reduce political risks and keeps costs lower. At the same time, Tesla's factories in Nevada and Texas are setting up special lines to make the condensed batteries using dry coating and advanced methods that use less water and are better for the environment. All of these steps show that Tesla isn't just making better batteries, they're changing how batteries are made, what they're made from, and where the materials come from. They are focused on controlling the whole process, from mining the raw materials to building the final product. This helps make their batteries cheaper, better, and more secure. Tesla's condensed battery is more than just a new invention. It's the result of years of planning, hard work, and risk-taking. It's a sign that the future of transportation and energy is changing fast. With this new battery, electric cars can drive farther, charge quicker, and become more affordable. And with plans to use it in robots, spaceships, and power systems, Tesla is aiming to lead not just the car industry but the future of energy itself. The world is watching closely because this might be the biggest battery breakthrough yet, and it's only the beginning. The introduction of Tesla's new condensed battery in 2025 changed the way people think about electric vehicles and energy systems. Even though this breakthrough is incredible, Tesla has said that it's not the final step in EV technology. This battery offers much faster charging, with a full charge taking less than 15 minutes. It also has better safety, with a much lower chance of catching fire. These features could make it easier for electric vehicles to become common everywhere. It might also help with other technologies like self-driving systems and clean energy grids that run on renewable energy. This new battery marks a big moment in the world of technology. In the past, battery changes were small improvements. But this battery is different. It brings major progress in how much energy a battery can hold, how safe it is, how fast it charges, and how long it lasts. These aren't just ideas anymore. Tesla has started using this technology in early production systems, and it plans to expand it at its big factories, starting with Giga Nevada and Giga Texas before the end of 2025. The effects of this battery are easy to understand. Cars will be able to travel about 1,000 kilometers or 620 miles on one charge. Phones might run for 5 days without needing to charge. And entire neighborhoods could be powered using renewable energy stored in these batteries, even when the sun isn't shining or the wind isn't blowing. The battery achieves these things because of new design ideas. One is using silicon nanowire anodes, which store about 10 times more lithium than the older graphite-based designs. Another improvement is using solid-state electrolytes instead of flammable liquids. The battery also uses a cathode with more nickel and less cobalt, which makes it cheaper and avoids rare and politically sensitive materials. The result is a battery that stores up to 450 watt-hours per kilogram, compared to Tesla's older 2,170 cells which stored 270 watt-hours per kilogram, or the newer 4,680 cells that store around 290 to 300 watt-hours per kilogram. This new battery was tested in a Model S prototype and an advanced version of Tesla's Powerwall. It solves one of the biggest problems in EVs, range anxiety, or the fear of running out of battery on the road. For example, a regular-sized electric car with this battery can travel over 1,000 kilometers on one charge. This was confirmed in tests at Tesla's Fremont facility in April 2025. Even with all this extra range, the new battery is still lighter and smaller than the previous versions. That makes it easier to design better cars that handle well. It also helps in public transport, trucks, and even aircraft that run on electricity. Making the battery smaller and more powerful helps in ways that weren't possible before. For example, fully electric planes for short trips and heavy trucks that can drive across a country without stopping to recharge are now possible. The battery also costs less to make. Since it uses less cobalt, which costs around $33,000 per ton, and more common materials like nickel, silicon, and aluminum, Tesla has lowered material costs by over 20%. With Tesla building most of its own parts and using advanced robots in its factories, it expects battery costs to drop to about $55 to $60 per kilowatt-hour by 2026. That's a key price point. At $60 per kilowatt-hour, EVs become as cheap as gasoline cars even without government support. This change means that people in places like South Asia, Africa, and Latin America could also afford clean transportation. It also opens the door for electric airplanes. Before now, these aircraft were limited because lithium-ion batteries couldn't store enough energy. Tesla is working with SpaceX and an aerospace company in California to test new lightweight batteries for drones and small planes. In early 2025, these batteries were tested at Edwards Air Force Base and managed 2 hours of flying on one charge, which is double what earlier electric planes could do. But despite all the excitement, Tesla still has big problems to solve. Making the condensed battery is very complicated. The parts that make this battery better, like silicon nanowires and solid-state electrolytes, aren't easy to produce. The nanowires need to be grown in special factories that are super clean and precise, just like those used for computer chips. This process is expensive and very sensitive. Any small mistake can ruin a whole batch. The solid-state materials also need to be laid out perfectly without cracks, or the battery won't work right. Scaling up production to Tesla's factory level isn't just about adding new machines. It needs new equipment, training for workers, and better automation. Even small flaws in production can lead to batteries that fail completely. Moving from making a few test batteries to producing millions each month in places like Giga Texas and Giga Berlin is a huge job. Another issue is getting enough of the right materials. Tesla is trying to avoid using cobalt because of its high price and the human rights concerns linked to mining it in places like the Democratic Republic of Congo. But now Tesla needs large amounts of high-quality lithium, refined silicon, and nickel-rich materials. Lithium is being mined from places like Silver Peak in Nevada and also bought from Australia, but the price has gone up and down a lot. In late 2022, lithium cost as much as $70,000 per ton, although it has come down to about $20,000 in 2024. Even though there's less cobalt, Tesla still needs very pure nickel, which is hard to find and often comes from countries with unstable politics. The biggest suppliers are the Philippines, Indonesia, and Russia. Battery-grade silicon also needs to be extremely pure, and only a few companies in the US, China, Japan, and Germany can make it. So Tesla now has to deal with global politics, not just prices. They may need to make long-term deals with mining companies or even own the mines themselves. Money is another challenge. Tesla spent billions of dollars on research, prototypes, and planning. These new batteries aren't a small upgrade, they're a complete redesign. Tesla's battery research lab in Canada, run with Dalhousie University and Jeff Don, made early versions between 2023 and 2024. These test batteries cost about $130 per kilowatt-hour, which is way above what's needed for affordable EVs. To lower the cost to $60, Tesla has to improve every step in the production process. Elon Musk has talked about using 3D printed parts, artificial intelligence to run factories, and modular factory designs. But most of this is still being tested. If anything goes wrong on the factory floor, it can cost Tesla millions of dollars. There are also problems with government rules. These new batteries use chemicals and designs that don't fit into existing laws. Tesla has to get permission from safety agencies in the US, Europe, and elsewhere. Each battery must pass tests for things like what happens if the car crashes, how it handles hot and cold weather, and whether it can catch fire. In the past, airplane batteries caused fires on Boeing 787s, so the aviation industry is especially cautious. Getting approval for these batteries could take up to 3 years in some places. That might delay Tesla's plans for planes, power grids, or buses. Finally, Tesla must convince regular people to trust the new batteries. Tesla fans already believe in the brand, but many others still don't buy electric cars. In 2024, only 8.6% of vehicles sold globally were electric. People worry about how far EVs can go, how long they take to charge, and how much they cost. This new battery solves those problems, but people might be nervous about a totally new kind of battery. Many don't understand what solid-state or nanowire means. For the average buyer to trust Tesla, they'll need proof, independent reviews, and real-world results. Tesla's past problems like car fires or issues with self-driving software mean that trust is already fragile. The new battery could change everything, but only if Tesla solves all these real-world problems. Tesla also faces a new kind of threat: politics. In early 2025, a movement called Tesla Takedown started. It was a peaceful campaign that asked people to sell their Teslas, stop buying Tesla products, and sell Tesla stock. This started in February 2025 and spread to hundreds of cities in the US, Canada, Europe, Australia, and New Zealand. The protest grew because Elon Musk had taken a role in Donald Trump's government as the head of a department that made big cuts to government jobs. People saw Tesla as a symbol of Musk's political actions. Some famous people like actor Alex Winter and activist Valerie Costa supported the protests. Some protests were creative, like flash mobs outside Tesla stores. But not all of it was peaceful. In parts of Europe, some Tesla stores and charging stations were burned or damaged. Protest organizers said they didn't support violence, but police in France and Germany are investigating. In early 2025, Tesla's vehicle sales dropped 13%, the lowest numbers since 2022. In countries like the Netherlands, Sweden, and France, sales fell by more than 30 to 60%. Tesla's stock dropped by over 30%, and the company lost $150 billion in value. Things got worse when Musk criticized Trump's budget plan, which included taking away tax credits for EVs and canceling federal contracts for Tesla. Trump responded by threatening to cancel all Tesla-related government deals. The stock market reacted fast. Tesla shares fell 14% in one day, and Musk lost about $27 billion from his personal wealth. Even though EV sales rose globally by 15%, Tesla's sales dropped in places where people dislike Musk politically. Banks like JP Morgan think Tesla could lose $1.2 billion a year from missing out on EV tax credits, and maybe $2 billion more if new laws hurt Tesla in California. Analysts called Tesla's 2025 performance a disaster. They believe the company lost around 80,000 sales because of its brand image, not because the factories couldn't build the cars. Some investors have warned Musk to focus on Tesla instead of politics. Meanwhile, the US government is looking into protests and attacks on Tesla facilities. In May 2025, Musk and Trump had a public falling out. Musk insulted Trump's budget on social media, calling it horrible. He later tried to take back his words, but the damage was done. Musk had also disagreed with Trump's trade war. Tesla depends on China for many battery parts, so when Trump raised taxes on Chinese goods, it hurt Tesla badly. China responded with its own high taxes on US cars. Tesla had to stop selling some models in China. Even though the Model 3 and Model Y were still made in Shanghai, the more expensive models were affected the most. China used to be Tesla's biggest market, but now its sales are falling fast. Tesla's Shanghai factory made 22% fewer cars in early 2025 compared to the year before. Now, Tesla is the third most popular EV company in China, behind BYD and NIO. People in China are unhappy with Musk's politics and the higher prices caused by tariffs. In March 2025, Tesla also had a big recall. It had to fix 46,000 Cybertrucks because of problems with the trim and accelerator pedals. These defects made the trucks unsafe. The company also had trouble moving from pilot production to full manufacturing. All these things combined to damage the brand's image. Musk now has problems in the US, China, and other parts of the world. Without government help or public support, Tesla is at risk of falling behind. At the same time, Chinese companies are moving ahead fast. In the first 3 months of 2025, BYD delivered over 416,000 EVs, while Tesla only delivered 336,000. That means BYD passed Tesla in global sales. BYD's batteries aren't as energy-dense as Tesla's, but they are safer and cheaper. Their main battery is called the Blade, and it uses LFP chemistry. It stores less energy than Tesla's batteries, but it's more stable and doesn't catch fire easily. The Blade battery has a strong design that saves space and doesn't overheat. That makes BYD's cars reliable and cheaper to build. Tesla still has better battery chemistry and advanced software, but its batteries run hotter and need better cooling systems. Tesla's design is more advanced but harder to make and more expensive. BYD is also growing fast in other countries. In the UK, sales of Chinese EVs rose to 9.4% of all cars sold in May 2025. Their cars are cheaper too. A BYD Dolphin Surf sells for about $23,000, while a Tesla Model 3 costs between $30,000 and $35,000. BYD makes most of its parts itself, which saves money. In 2024, BYD made over 4.2 million vehicles, and 70% of the parts were made in-house. Another strong competitor is CATL, a battery maker from China. In 2021, CATL had over 30% of the global battery market. It's building new factories that will make even more batteries, reaching up to 800 gigawatt-hours by 2030. CATL is also working on new battery types, like sodium-ion, that might be cheaper in the future. BYD plans to release new charging systems that add 400 kilometers of range in just 5 minutes. That's faster than Tesla's current systems. While Tesla focuses on research and vertical integration, political problems have weakened its position. Chinese companies are getting support from their governments and expanding quickly. If Tesla doesn't fix its political issues and stay aligned with global regulations, it may lose its place at the top of the EV market. Thanks for watching. Keep it and stay tuned. Like and subscribe our channel. Have a good day.